I think we're on, right? Are we on? Yes, we're on. Okay. So let's look at something a little bit more complicated. Let's say we have, and we'll balance it too, so we could practice. Let's say we have C3H8. That's actually propane. Okay? And then we have O2. And we produce, it's a combustion reaction, so you're going to produce carbon dioxide and oxygen. Okay, it's like it's respiration, although you're using other types of things here. But combustion is like a respiration reaction, where you're producing carbon dioxide plus oxygen, plus you're also producing energy, the built-up energy within the hydrocarbon, as opposed to glucose, where glucose you have you have oxygen in there as well. Anyway, so right. So you want to balance this first. So you want to balance the carbons. Then you want to balance the hydrogens. Okay. Sorry, O2. Sorry, I'm ahead of myself here. H2O. Okay. You want to balance the hydrogens, so that's 4. Right? So then you have 6 oxygens here. Correct?
Yeah.
Yes? And 4 there, that's 10. So you need a 5 here. Clear? Okay, now what you're going to do is you have your stoichiometric equation, and then you want to write your stoichiometric masses. Remember we did that? Where as you write it, you think of it in terms of moles. And you know what the gram molecular weight is. You take the atomic weight of the particle, right? So this is going to be, what? 3 times 12 is 36, plus 8 is 44, is that right? Is that right? Am I doing that right? Isn't carbon 12? 3 times 12 is 36, plus 8 is 44, is that right? Yes? Okay. So that's 44. And then what's 5 oxygens going to be? 32 times 5. 30 times 5 is what? 150?
Yeah.
Plus 10, right? 160? Is that right? 160? Right? And then what's 12 plus 32 is 44. 44 is what? What's 3 times 44? Well, 3 times 40 plus 12, right? What is it? What's 3 times 40? What's 3 times 4? Isn't it 120? 132 plus 12? 132? Look, learning chemistry is not important in high school. Learning how to reading really well, writing really well, basic math, mental, and speaking in public. So when I say, what's 3 times 44, that's probably in some ways more important than the chemistry we're doing. Being able to do very basic mental math. It's important to be able to do that. Anybody can ring a bell in here? Well, how do you ring a bell? Ring a bell, yeah. You should be able to do mental math like you're ringing a bell. Yeah? It's easy stuff, okay? All right, now. And then, what's that? It's going to be 18, right? 16 and 2 is 18, right? What's 18 times 4? Well, let's see, what's 18 times 4? What's 18 times 20 is 80, minus, so what is it? 72. Okay. Yes, are you with me? You with me? Yes? Yes? Okay, good. Let's, because of time, let's combine what we're doing with mass, and let's do mass, and let's do everything together with one major problem. Okay, so let's say I have 100 grams of this and 100 grams of this. Let's say I have 100 each. I could have different amounts, but let's say I have 100 each. Okay? Yes, is that okay? All right. which one is going to limit the amount of carbon dioxide produced? In other words, am I going to use all of this and have some of this left over? Am I going to use all of this and have some of this left over? Or am I going to use all 200 grams of reagents? Am I? Am I? Do I use equal amounts? Do I use equal amounts of propane and oxygen? Do I? Yeah. Look at it, 44. For every 44 grams of this, I need 160 of this, right? Right? Yes or no? Yes? Okay, so which one's going to limit the reaction? Then how much of this am I going to get? Yes? Okay. So what we're going to end up calculating is called the theoretical yield. That's what we're actually going to end up calculating. What is the theoretical yield? But we've got to find out which one is limiting. Otherwise, how can we compare? Do we compare this with this or this with this? What do we do? Right? So you take one, you compare it to the other. Easy? What does that mean? Well, I'm not going to tell you. Let's see if we can figure this out as we do it. All right, so we're going to compare these two, right? That's the constant ratio, right? And we're going to use proportional relationships. The book uses factor label method, and it really doesn't demonstrate any chemistry. It's just kind of a brain-dead technique that some guy came up with years ago. But I want to do it more using proportional relationships, some basic 7th grade math, and yeah, where you're actually demonstrating constant ratios. Yes? Okay. So you're going to compare these two, right? So what's the constant ratio? Well, it's going to be C3H8 over 5O2, right? So for every 1 mole of this, I'll use 5 moles of this, right? Is that right? Easy? Okay. So, well, what's the constant ratio? What's the constant mass ratio? Well, it's going to be 44 over 160, right? Is that right? Right? So, okay, all right. So if I use 100 of this, how much are we going to hear? So in other words, 44 is to 160 as 100 is to what? How much of this am I going to need? I'm comparing these two. So if I use 100 of this, how much do I need of this? All right, so I say, all right, fair enough. So it's going to be 100 over x. So what's 160 times 100 divided by 44?
Yeah.
What is it? I can't hear you. What is it? If I use all of this, how much of this do I need? Come on, you can do this, right? Do you have a calculator?
363.63.
So this is x is going to be 360. Let's just round to ones place, guys. Just give me. What is it? 363. Good. So if I use all 100 of this, right? I need 363 of this. Do I have 363 of this? Do I? So which reagent? Reactants, reagents, same thing. A reagent is a reactant. A reagent is a reactant. Products, reagents, yields products. Reactants yields products. Yes? So which one's going to limit the reaction? What don't I have? That's going to limit?
No.
Is this one? Yeah, this is going to limit, right? Isn't this going to limit? Right? I can't use that, because if I use all this, I don't have enough of this. So do you understand when I say limiting reaction? I mean, limiting reagent, I mean what I say. Right? What's limiting? All right, so let me ask you another question. Yes? There's something on this? Is it?
It's low battery.
It says low battery. Well, let me... what I want you to do here while I fix the battery thing is I want you to tell me, all right, that's limiting, right? If that's limiting, how much of that am I going to have left over? So do that right now. If that's limiting, how much of this am I going to have left over? Let's go. Okay? All right, shall we do that? So, can I erase this? And we'll keep the constant ratio. 44 over 160 equals x over 100. So what's x equal? What's x equal? 44 times 100 divided by 160. You do understand that this is 7th grade math, right? You do. And I would need a calculator. So where's your calculator? Mr. I like to clean out lockers. What is it?
27.5.
What is it? Just give me ones place, man. Just give me, do yourself. 27, okay. So 27, right? Okay, cool. So I need, if I use all this, I need 27 of this, right? So how much is left over? 73. So 73 excess. So I need 100 of this, 73 will be in excess. 100, I need 27, right?
Yeah, 27.5.
Well, whatever, ones place is fine. Yes, you get it? You get it? So now, okay, that's fair enough. Well, how much of this am I going to get? How much carbon dioxide am I going to get? How much carbon dioxide am I going to get? So I'm going to have 73 excess. All right, so let's do this. Let's say, so I'm going to compare this, right? Right? Yes? This with this? So let's redo that. So, okay, fair enough. Okay, well, so we'll say, right. We'll say 502 over 3 CO2, 160 over 132 equals 100 over X, right? So it'll be a little less, right? It'll be like what? I don't know, a little less. You see that? This is this, this is this. So what's the answer? 83 or guessing?
82.5.
So 83, I was right.
Yeah.
A little spooky, a little spooky. Darcy's being creepy again, okay? All right, so X equals 82 grams CO2. That's called, you know what that's called? That's called the theoretical yield. That's called the theoretical yield. Okay? All right, if that's the theoretical yield, all right, fair enough, right. Well, let's say the actual yield, I spilled some, you know, I'm a slob, right? God, I'm a slob. Talk to my ex-wife. Whoa, slob! Okay, so I get like, you know, 60 grams instead. I'm a slob. Okay, fine. Can't follow directions. My idea of making a cake is unleavened bread, okay? That's called my actual